Okay, we're recording. Thanks everyone for joining. Really appreciate the amount of RSVPs and actually quite good attendance that we've got as well. So I'm not sure who was on the previous meetup, the virtual meetup at least, or who's been to other meetups in the group. But just for those who don't know, my name's Tim. I'm the new-ish solutions architect for the Elastic Africa region. I've been around, sorry, it's lockdown time, so and I'm likely to get interrupted at some point by small children. But anyway, we'll be fine. So I've been with Elastic for around 7 months. I look after the Africa region and also some of the UK. And basically, yeah, I'm the main sort of pre-sales person on the ground in the country. We have a sales rep as well, who I see some of the people on the call. Craig would have met Craig before. He's based out of London. So in terms of people on the ground in South Africa, it's myself, Johannes, he's got that lovely Elastic background, Damien, I don't see Dave Ross on the call at the moment. So Johannes, Dave, and Damien are part of the support team, and I'm part of the sales engineering or the pre-sale team. So I work with a lot of partners and customers, and I'm also responsible for liaising with the community as well, the dev community. So anyway, that's me, quick high-level catch-up for those of you who weren't in the previous call. Two things, I think. I moved the time for the meetup to during office hours, so end of the day, but not sort of from 6 o'clock onwards, just because I figure meetups are normally in person and in groups, and it's also, they typically involve beer and pizza, so that's why they're from 6 o'clock onwards. But the virtual ones, I mean, you don't have to go anywhere, and in my mind it counts as a meeting, so that's why we stuck it at 4 o'clock today. But if anyone has strong feelings about this, because my plan is to keep doing them at 4, but if you have strong feelings to the contrary and would like to see them after hours, by all means, please let me know. I don't think my mail address is on the presentation, but I'm fairly easy to contact. It's just tim.brophy@elastic.co. Or please comment on the meetup page or anything if you feel like you need to get that time amended. So today we've got a sort of, because there hasn't been a lot of time since the last meetup. The last meetup was kind of halfway through April, and now we're doing it sort of early in May. And the reason for that, which is my second point, is that Elastic has a global all hands event, which is happening for the next 2 weeks. So it's a sales kickoff, and also because it's the start of our financial year, and also an engineering all hands event. So typically a lot of us would have been in Chicago next week, but obviously COVID has put paid to those plans. So we're all doing that remotely, and basically we're trying to coordinate, multiple time zones. And for the next 2 weeks, my calendar is fully booked in this time zone, or this time slot anyways. So it wouldn't have been possible to do a meeting for the next couple of weeks. So I figured let's just pull it forward rather than waiting for an extra 2 weeks. So that's why we're having one quite soon after the previous one. And we'll probably revert back to something like a mid-month again in June. Hopefully the world is a little bit more normal then, but I sincerely doubt it. I think we're going to do the virtual ones for a while still. Okay, so I'll stop rambling and get onto the agenda. So first of all, let me keep rambling. Before we go onto the agenda, I do want to talk about 7.7. I can't share any slides about 7.7, and I don't think, I think the release, basically the framework or the main features in the release have been decided on, but until we start to sort of formally make announcements around 7.7, I sort of have to be very vague on some of the details. If you've been using Elastic or in the Elastic community for the last while, certainly for me, having been around and sort of paying attention for about 12 months now, the frequency of minor releases, but has been like quite surprising. I mean, every 3 months we release a minor release, but what's been really amazing to me has been the amount of features and capabilities that we're adding to each minor release. I mean, we're adding stuff that a lot of vendors would be fairly proud to call a major release, and we're doing that three, 4 times a year. So I think the one thing that has been published around 7.7, and there is a blog post around it. If you have a look at the link I've got up at the moment, so elastic.co blog, and then the filter by releases, you'll start to see the official communication come through about what's in 7.7. But there is a blog post in there at the moment, which talks about how 7.7 is going to use less heap memory. So basically, you don't have to commit the same amount of heap as before, because we're moving some things onto disk, and the blog post really does a much better job of explaining it than I ever could. So I think it's got a lot to do with Lucene as well, but fundamentally what we should be doing is seeing a lot less heap memory requirements from 7.7 going forward. There have also been large improvements and functional enhancements to alerting throughout the platform. So that's really something that you're going to see. Observability as well as security is improving alerting. A trend that we've been following for the last couple of releases is predefined detection rules in security, and machine learning jobs as well, that basically are predefined that you can work off of as a base. So there's obviously enhancements to those, and new rules and relationships between machine learning jobs and signaling and detection rules. Some interesting stuff around our cloud integrations on application performance management. Again, so the details of those will be published in blog posts. I just want to make sure there's nothing else here that I need to look at. If you're a big user of Prometheus, you're also going to like what's coming. So yeah, without diving too much into the detail on that one, please keep your eyes open for 7.7. It literally is. It should only be a week away, based on what I understand. Then again, I mentioned the fact that the world is obviously in turmoil, and we're not able to go anywhere. So same slide as last meeting. We've got this campaign called Elastic Connect. So we have a lot of webinars, some virtual events that have been scheduled. We have a demo series running, which I think will probably going to take a little bit of a backseat over the next 2 weeks, because we have our all hands events, but you'll start to see that ramp up again towards the end of May. And yeah, we've also got some training, which is normally paid for training, which has become free. So it sort of rotates, and the time frame that the training is available is fixed. But just keep checking back for updates, and you might get yourself some free training during this kind of COVID lockdown period. Okay, so that's kind of the pre-agenda, and then today's agenda would be a quick machine learning demo from me. I see we're already at 15:15, so I'll hopefully only take 15 minutes to do that. That one's going to be fairly high level, just show you how you can kick off with machine learning jobs, and you don't necessarily have to get platinum licensing to use that. Then Salva, sorry, from Deimos is going to, Salva, there we go, I got it right the first time, will be giving a quick presentation about Homechoice's observability journey. So Deimos is a partner of ours. Salva will introduce himself and explain Deimos and what he does at Deimos. Really that will be about how Homechoice went basically from, I guess, their legacy platform into adopting Elastic for observability. And then up until 30 minutes ago, I didn't have it today, I learned, but I'll go across quickly just for, got Cabana saved objects in the TIL section today. If anyone else actually has anything to contribute there, I'd be very, very grateful. So if anyone wants to share anything, just like a small nugget of information about Elastic or Cabana or Logstash or any of the beats that you want to share. And if you think about that in the next half an hour, by all means, jump off mute during that section. Cool. Anyone got any questions or things they would like to see or discuss in this meetup before we kick on? Just use this opportunity to take a drink. No, all good? Okay. Thanks. Okay, cool. Got a lot of people on, let's see. Okay, all right, so machine learning. So machine learning, and I think you should see my Cabana instance. So this is my sort of, because we're part of the Elastic engineering team, we're allowed to stand up little clusters in Elastic Cloud, and we don't get billed for them, which is very useful when running little projects and trying to show things when we don't want to use the demo environment. So this is a standard Elastic Cloud deployment. Now, machine learning is technically a platinum feature, but there is anomaly detection and a sort of limited capability version of machine learning that is available in cloud. So I'm going to use that just to run through just a high-level introduction to machine learning. And the big thing is, I think if I've done my job correctly at the end of a demo, you should be fairly underwhelmed because it was surprising to me at how simple and easy the machine learning features in Elastic actually are to switch on and use. So what I'm going to do is I've come across to the little machine learning tab here. I think it's actually a module. It should be a module in the certified engineer training, basically, to figure out what each of these menu items is without having to expand it. So you work on the icons. This, I will say, in future versions, I think that they're working on a bit of a UI change that may be improved in future. But basically, in the cloud available version of machine learning, you have anomaly detection, data frame analytics, and then the data visualizer. I'll focus on the anomaly detection for now because basically it's the one that's going to be most useful. The rest of the sections you can easily play with. But I'll set up a new anomaly detection job. So I've been doing some stuff using classifications and predicting things like what am I going to spend on my credit card in the next 2 months using existing credit card transaction data, just an experiment. But I won't do that because this is recorded and I don't want to show that until I've found some sample credit card data to use rather than my own. But what I will do is use the Cabana Sample data log. So I've used one of the data sources here that we make available with Cabana, and you can add that. I think when you first kick off Cabana and you start up for the first time, so you can add that data to play with. So you don't have to bring your own. So these data logs are basically HTTP logs. I believe the source is Apache. And I'll take you through 3 different jobs that I can set up. So the first one, and basically the whole thing is wizard based. You can dive into advanced if you want to and work on it using JSON, but it's really easy to do these detection jobs using a wizard. So the first thing is this basically frames out for you the time range that you want to set this job to learn from. So that basically sets up a quick, like a 15-minute window. But what I'm going to use is the full range. And the first thing I do want to point out so that you don't think I'm fudging things is that these logs are sort of automatically generated and they are generated into the future. So they're synthetic, right? So they're not real logs that come off web servers. So they're just created using some generators. So these dates do go into the future, so please don't think I'm sort of hijacking the system here. So I want to use the entire length of time to train the model, right? And then I'll say next, and it's a single metric view. So what I want to look at is, I think for this one, the most simple thing would be, I just want to count the amount of events that I'm getting, right? So the amount of log entries. I could say I want to do a count, but I want to favor instances where the count is very high, or maybe I want to favor the model to look at instances where the count is very, very low. And then I can basically, you'll see that the field name that's in the log file is here, or the field name, sorry, that's in the document is here, and then you've got your different functions on that fields that can be calculated. So minimums, maximums, high, mediums, low, mediums, that sort of stuff. But let's just be very simple. Put in an event count, and you'll see that this pretty much flows across, and it's quite uniform. You can already see that there is an anomaly across the time span. Now, the next thing that you need to choose is the bucket span, right? So you could say what is the time range on the buckets that I want to use to calculate the job? Easiest thing is to tell the model, well, you estimate what the span should be. What's the right level of granularity for that? Okay, so next, just give it a quick ID. So we know which one it is. I'm just going to say single metric. Again, say next. That's so simple. It then does a validation and checks the information, checks the fields that you've got, and decides whether or not it can actually do a calculation, build a model on that. So that one obviously was successful. Quick summary of the job, and now we can go and create the job. So it should start to learn it as we go along. And while it's doing that, we can actually go and view results as well. So why did that? Oh, there we go, view results. Sorry, the button moved. So viewing the results opens up a second window, but you can see here that a couple of things have happened. So obviously it begins learning, doesn't have enough of a reference to work from, so it can't really figure out what the upper and lower sort of averages should be. And then it starts to build a pattern of acceptable ranges as you go in and out. And then you can start to see, well, here's a deviation, an obvious deviation from the norm on this data here. So let's have a look at the results in more detail in this next tab. And now you can see it basically zooms us in on the last little period of time on the logs. But we can see that there's an anomaly over here. So let's go and look there. So let me zoom out quickly so you can see. But basically, you can see that the model goes and calculates what's an acceptable maximum and acceptable minimum, and when will I expect to see that, right? Based on previous data, and then it'll generate like anomalies where the actual doesn't match what the model is expecting. So let's zoom in slightly and only look at the anomalies that get raised. So here we have an anomaly where there's basically much less traffic than what it's expecting to see, or much fewer events log entries. However, it's not dramatically different from what that lower median is. So it doesn't give it a very significant weighting, which is why it's just kind of, you know, doesn't jump out of you. It's not a big red line. If we go to this little anomaly that happened over here, you can see it's got quite a significant score because it's dramatically outside of the bounds of what the machine learning job is expecting. So you can see that these jobs then get listed out here. And if you were running something like an APM, which is another demo I've done recently on the Open Digital group, and maybe we should do it here as well. But if you're running APM, you could then, from this view, instead of only being able to configure the rules, you could actually go and look at the all of the log files that contributed to that anomaly score, and go and look at them in different views, like infrastructure log views, metric views, and application performance management views. But then you can see that basically it's picked up that there was an error in your transactions. And, you know, maybe when you're working on a small time frame or an anomaly that isn't so dramatic, it'll be difficult to pick up. But this is going to find it for you, especially, for example, this one, you know, if you zoom out a lot, that lower error, for example, isn't that obvious, right? Where the traffic was a lot less. It's not something that really jumps out at you, but the model did still pick it up. What's quite nice is that you can then still forecast what your traffic might be, let's say, over the next 14 days, just based on what you've seen in the past. So let's just zoom out slightly. So you can see that your forecast then would predict what your patterns would be going forward, which is quite useful. So we'll go back to, let me click out of this one because this is my results view. We can go back to our, oh, something that I missed out there was the fact that you can create a watch based on that information as well. But let me do that when I do the second one. So actually I'm gonna skip the multi-metric one. So you can do the same thing. Actually, let me go do it. It's pretty quick. So let's do a multi-metric. Again, we'll use the full time span. Let's look at event count, same thing. I'll just leave that single metric, but what multi-metric lets me do is then add a split field. So now I can do something like, well, I'd like to see all of my results split by response keyword. So I know if it's a 200, a 503, or a 404. I'll do the same thing. So my bucket span, in this instance, it's recommending a bucket span of 3 hours. I can't remember what I did for my previous one, so the naming is going to be off. Okay, and we'll train that out. So again, so I was saying earlier, like, you know, if I've done my job correctly, it should really be quite underwhelming. To be able to achieve this in, like, you know, if you were to build a model in Python or any other tool, would be something which wouldn't take all of 5 or 6 minutes. So it's really, I mean, the fact that it is so simple to set up is I mean, there's a lot of benefit to it. So basically, what we're seeing now is an anomaly timeline. You're now seeing this. It looks a bit more like the view that you might see in that ABM demo, but you can see that over time, you've got some anomalies that have occurred and what their impact and score might be. And we've got this red one over here. What's quite cool is that you can see that this one, for example, which is quite a high severity, like obviously there's a significantly higher amount of events that got tracked on this one. You can see that the influencer there was that it was a 404 response. So someone was either trying to look for a page that didn't exist, or there was something deleted from the server, or I mean, you could think of a million scenarios, it just wasn't available. So now you can tell why, or now you can figure out, well, I've had a huge amount of events on that particular day, and it's most likely because I've got a 404 error. And again, here you can see that the influence, or the score, sorry, of the different influences does come up, and you can see dramatically that the 404 has a much higher influence than the 200, for example. Let's see this in time series. Right, so there you can see like there's a whole bunch of 404 issues that come up there, and you can filter it by 505, 503, or 200s. So it's quite a nice way of splitting how you represent your basically your visualizer for the machine learning job that you created, or the anomaly detection job. And you'd be quite specific on that one. It's an anomaly detection job, not necessarily a machine learning job, even though it's based on machine learning. Okay, I'll do one quick one. This is, I'm going to use this one up here. So if you basically didn't want to go and experiment and run through this stuff on your own, the quickest and easiest way to set up an anomaly detection job using machine learning is to go and use the sample docs that come up. So if you build from the sample docs, you'll see that you get three jobs that get pre-configured for you. It's this low request rate, right? So unusually low rate, response code rate. So that's basically the one that I just did for you now, but it's just a little bit more detailed. And then URL scanning. So you can find client IPs that are basically looking for an unusually high count of distinct URLs. You basically say, well, it's going to go and create those jobs, but we need a prefix just so we know that they've been created by me or they're for a specific purpose. They'll use the Cabana sample data and the Cabana weblog. So those are groups that these will be added into. I can go and create those jobs, and then everything that I did manually, that just gets created like in the background using templates. So you can see that now I've gone from having 3 different jobs to 6. So here's the low request rate, the response code rate, and then the URL scanning. So let's have a look at that one. So now this would do a scan of the logs and try and find a particular instance where a distinct client IP was scanning an inordinate amount of URLs. And let's zoom in on that one so it's a bit more visible. But you can basically see here that on this instance here, this client IP was scanning 88 different URLs. Okay, so that's machine learning, basically a very, very high level basics of it. I mean, the best thing to do if you have data to play with, I mean, the Cabana sample data is quite nice to get the sort of just to get decent results, so that you understand how to work on it. But the best thing to do is to take your data and start to play around. It's a good point in time for me to mention that we have a 14-day trial on cloud, so you can at any point in time go in, build a deployment. You have a cap per node of 4 gig of RAM. So obviously it's not something you can start to channel production data through, but you have a 14-day no obligation, no cost trial. I don't even think we take a credit card number. And if at the end of 14 days or if halfway through you want to extend that trial, you want to try something else, or maybe increase the cap, let me know, because we can extend that to 30 days, and we can also get approval for trials in the cloud that are bigger than those 4 gig of RAM per node. So then you can try out machine learning and other sort of more advanced features that we have deployed. Okay, anyone got anything to add? Questions? Do I need to go over anything? Okay, everyone still with us. Shelva, I'm used to WebEx when I hand things over, so normally I would give you the ball, but I don't think Zoom's got the concept of a ball. So I think you can just share screen. Shelva, are you there? Yes.
Can you hear me?
Yes, we can. Yeah.
How's my audio? It's all right.
I can hear you fine. Yeah, that's no problem.
All right. Okay. So hi everyone. I'm Shalva. I work at Deimos. We are a developer and security operations company. We're based in Cape Town, though we actually have a global team. Personally, I am based in Lagos, Nigeria. So Deimos, we have a lot of DevOps and software engineering experience on our team. We help companies build scalable and secure infrastructure, typically on the cloud. we also help them improve on their software development workflows and practices and measures to ensure the quality of the software. Typically, we work with the company's resources and their team. We come in and work alongside them and exchange knowledge and fill up the gaps and help improve everything. So Homechoice is one of the clients that we work with. It's probably going to be more familiar to most of the people on this call than to me because Homechoice is quite a popular retailer in South Africa. We do a number of things for them, but when I joined Demos, not long after I joined, one of my projects was to help out on Homechoice observability. So as of then, I don't think anybody actually mentioned observability then. But there was the general mindset, the idea that we wanted to get more insight into the applications, wanted to understand infrastructure and all that was happening better. So the current status of things, as I think,
Yeah, see, sorry, can you hear me? I can't hear Shalva anymore.
We can hear you, but I can't hear someone.
Yeah, okay. Let me see if he's still on. No, he's on mute. Shalva, are you back? Shalva, I think you might be on mute. Yeah, unmute yourself. There we go.
okay. Can you hear me now?
Yes, we can hear you now, yeah.
Okay, so there was an existing Elastic installation on EKS then. So that was what was being used to monitor applications as at then. So one of the first tasks I undertook then was to improve the logging infrastructure. So back then we were sending logs already through Firebase and Logstash on EKS, sending to Elasticsearch in AWS. And we wanted to improve what we could get, the information we could glean from the logs, because it was initially just simple log strings. What we did was in configuring them logs in JSON format. So rather than just dumping out the information as strings, we use JSON, so we could add extra contextual information as needed. This enabled us to easily search and filter on this in Cabana, because Elasticsearch, it shines as a powerful search engine. That's one reason why it's so good for this use case. It's a powerful search engine, but beyond that, it has so much more. And if you're simply doing full text search, like suppose you want to find all usages of or everyone you want to follow the path of this customer, for instance, with the tracking ID. You're doing a full text search for tracking ID that has this, or you're looking for info logs. You look for all logs that have the word info inside of them. This will pick up both actual info logs and any other false positives that have info somewhere in the text. But you could do much more with Elastic by actually extracting the log level into a specific field and parsing that. So you filter instead. You ask Elasticsearch, okay, I want logs that have a level of info, or I want to fetch logs that have this tracking ID for the customer access. And so that was one of the first moves we made. Another move was splitting the logs from different sources. So we had logs coming from Nginx controller and applications as well. So we decided to split them up so that we could more easily filter through them in Cabana. We sent logs from applications to a default index. Then for Nginx controllers, we sent them to a separate Nginx index. And for other applications like file bit, metric bit, and any other internal applications running in this kube system namespace, we sent them to an internal index. So the benefit of this was we could filter in Cabana. When we select an index pattern, we don't have to look at all the logs. We could specify, or we want to look at this index pattern logs app star, so it will give us only logs from applications, or we want to look at logs from Nginx, so we would select logs Nginx, and we could manage their lifetimes and data retention separately, which was one of the next things we did. We configured index like lifecycle management on how long we wanted our data to be retained and what to be done with it after that. And another thing that we also went into was APM. I think we were already making moves for this when I came on board. And we had APM, for those that are familiar with it, gives you information, insight into the performance of the application. Like you can see on this graph, for instance, you have requests. These are requests that users make to your application, and you get information about the duration and 90 percentile. So you have the statistical measures or your requests, and then number of requests you get per minute and the impact it has on your overall system. So you could analyze the performance, like 500 requests that return 500 errors. How often did they occur? And you could look at a sample of such a request and trace the path of the request as well through your various services. So when I joined, we actually had some. I think getting started with APM then. So we started with a Node.js, a few Node.js apps, and played around with that. And then we added it to Java applications. And eventually, as time went on, we began to add it to more applications to monitor them. We actually went live with the .NET agents on the day it came out of beta. We were already playing around with it before it was ready for release. And on the day it came out of beta, we went live with it. Now they're monitoring over 60 applications, mostly in .NET with Elastic APM. And recently we are also adding real user monitoring, that's monitoring from the front end, JavaScript, error stream on the front end, performance that you see on the front end. And next thing we went into was metrics. So first off, we were just doing some light monitoring of EKS nodes with metric bit. And more recently, we added some monitoring for on-prem machines as well. And we are also experimenting with monitoring RabbitMQ queues to keep stay on top of what's going on in there. And then a really interesting area I went into was collecting custom metrics. So we needed to collect custom metrics as more information about what's happening in applications. Like you can see an example here where we want to track how many orders we received, for instance. And by using structured logs in Firebase, we actually made this possible. We could have logs where each single log entry serves dual function. So it's both a log entry and it's also a metric entry. So for instance, you could say, give me all the log entries where the message is order received. And then you have the number of orders you've received in the last hour, for instance. So because none of the Elastic agents, the APM agents supported custom metrics directly as at then, so we went ahead with this solution. And then from metrics, the metrics actually don't have any use without visualizing them. And we started off with simple visualizations, basic information like error logs and logs per service. So you could see error occurrences on this graph, like how frequently do we have errors showing up across our services, and then the top errors that we've encountered grouped by service as well. And this was nice for a start because we could come in and take a look at how our applications are performing. And over time, we went further to dashboards that are showing business metrics, not just application metrics. So dashboards for things like sales, orders, deliveries, all of this, we could actually view them right from Cabana, because the basic principle of the whole visualization is that if it's an Elasticsearch, you can visualize it, you can place it on the graph. So we could have graphs and charts like this that it's not just information for the developers, the engineers that want to know about the application, but information for the business people as well. And we could track deliveries and orders information as well, like the orders, number of orders we've received, orders that were filled, orders that we've handled successfully, and yeah, things like that. So not long after that, we came to I say, fork in the road, or a major turning point for us, where we decided to migrate to Elastic Cloud. The reason for that was because we realized that we actually wanted to focus on the value, the usefulness we get from this, not just spend our time, rather than spending our time on maintaining it or trying to make sure that all the nuts and bolts are working properly. So Elastic Cloud is a managed solution by Elastic. So you don't manage the hardware yourself. Elastic takes care of that. You simply sign up, and with a few clicks, just like Tim showed us, you can create a cluster. So at this point, this was when we realized that, okay, this was something bigger than us. As at then, we actually were going somewhere with this. We wanted to step back and take a look at what we were doing and where we wanted to go. So we came up with an observability strategy to describe what we were doing, what we wanted, the aim, what we wanted to achieve from all the things we are doing, and then the requirements of the solution would pick, and a plan to implement all of this. And this helped give us a clear idea of, okay, these are the things we should be looking for. These are how we should go about it, and these are what we need. So we did some cost benefit analysis. We created a migration plan where we looked into the current setup we had, the proposed setup we wanted to go to, and the reasons for that. We tried to estimate the specifications and the costs that it would involve to migrate. And we considered some other things as well, like the security of the new setup and how easy it was to scale it. And then finally, we detailed the process we would go through to migrate to the cloud. And well, it took a while, but after all of that, we got it approved and we began the migration process. And well, in the long run, the result of the whole thing was first of all, we got to manage reliable hardware. We no longer had to worry about managing hardware ourselves. Like we didn't have to bother about keeping Elasticsearch up to date or watching over the nodes and all of that, because all of that was on Elastic Cloud. So literally with a few clicks, we could scale up or scale down, and we could see information about how our hardware was performing if we wanted to know. And this freed us up to do more. Actually, we could focus on improving our observability. We could focus on getting more insight into what was going on in applications rather than worrying about the hardware. And as a bonus, we also got instant upgrades, because when we're using AWS Elasticsearch service, we had the problem where it was tied to a specific version of Elasticsearch. Because it was a customized version of Elasticsearch, so there were limitations, and also AWS was much slower on upgrades. So I think at that point, Elasticsearch was like 7.2 or something, but we only had access to like 6.5 on AWS service. So by moving to Elastic Cloud, we could upgrade with the click of a button whenever a new version came out. And we could take advantage of all the new features and the purposes. And it sounds like a marketing pitch, but it actually has come in very helpful for us. Another thing we added as we went on was uptime monitoring with Heartbeat. So uptime monitoring basically to stay on top of your services and know which ones are responding and which ones are up, which ones are down. We start with basic checks where you have a simple Heartbeat configuration like this. You have your URL that you are checking to see if it's up. You check it at a specific schedule and you look for the response, a successful response with some data inside of that. So we went up with that, and as we got more comfortable with that, we added more details over time. Like we added more checks from multiple locations, which is a very nice feature that Heartbeat allows you to do. So rather than just, especially if you're serving a global audience, sometimes your service may be reachable from one part of the world but not accessible in another. So we added more checks from different locations and different kinds of services, not just HTTP services with different schemes and ports, like you can see on this graph. So here we're actually checking HTTP, ICMP, and TCP services from 2 different locations. And right now we're monitoring over 50 services. And then from there we moved on to alerting. We looked into adding alerting because without alerting, most of this is still very stressful. I mean, you have to come in yourself to look at the dashboards and see if there's anything wrong. But thanks to Elasticsearch Watcher, we could easily alert on service downtime from heartbeats information. Like in this example here we have a simple watch that runs every 2 minutes, and it checks for the uptime information inside of heartbeat for any URLs matching this. So if the value of the most recent check is not up, that means it's down, and so there's a problem. So we send an alert to our Slack channel that our URL is down. So this is a pretty straightforward check, and eventually we moved on to checking on business metrics as well. Like we want to alert on when we haven't received any new orders in a certain time frame, like the last 2 hours. It's very likely maybe something has broken somewhere and we aren't aware of it. We could adjust that as different time periods. For instance, in a period of heavy traffic, we could change the watch to alert us if we haven't received any new orders in the last 1 hour, for instance. So, and the base of the whole thing is that if it's Elasticsearch, you can alert on it because all of this is an Elasticsearch query that is here. So you write an Elasticsearch query and it powers the rest of the alerts. And so from a more complicated step that we moved to was bringing in Logstash for all of this. Personally, I actually avoid bringing in Logstash unless I have to. I try to keep things simple, going straight from PowerBeat or Metric Beats directly to Elasticsearch. But we realized eventually that we needed to bring in Logstash. Why? Because first off, we are trying to ingest from multiple sources. We start off with just taking in data, logs, and metrics from our EKS applications, but eventually we wanted to also ingest from applications in AWS EC2, like I mentioned earlier, and on premises. And not all of them use the same format, so it wasn't going to be straightforward. And if we are sending directly from each of them to Elasticsearch, it will be difficult to run the same search queries and filters on the results because they were in different formats. So we decided to set up Logstash for that. We also needed to do some web processing as well. Remove some duplicates. Some services were actually logging duplicates, mostly because there was a human readable version and there was a structured version. And changing that might have taken more work than was needed. So rather, we decided to remove the duplicates on the other end, on the Logstash end, and set any fields that needed to be set, like let's say a log level if it wasn't present. And so we started off, we installed Logstash on EKS. Unfortunately, there's no Logstash supported on Elastic Cloud right now. Hopefully that comes soon. So we went with the Logstash installation on Kubernetes. And what we were doing there was receiving logs from EKS applications and Nginx. Like here's an example of the filters that we have. So we had filters, like over here, we are actually trying to normalize the format of our Nginx logs. So all of this it looks quite complicated, but it's not as complicated as it looks actually. This is a simple format that you can learn. So because the reason for this was because the Nginx applications, the Nginx controllers that were on Kubernetes were using a different log format from the ones that were on AWS EC2. And we wanted to be able to filter on them in the same way. So for instance, we wanted to be able to filter, okay, give us the 404 responses, or give us the 500 responses, or give us requests that come from this referrer, or give us requests to this URL. But with them in different formats, we couldn't do that because, I mean, it's either you only have this information captured or you only have the information for the EC2 logs captured. So, but we set up these filters to extract data from both the Kubernetes logs and the EC2 logs and present them in the same formats and output to Elasticsearch. And we also set up an installation of Logstash on premises later. The reason for this was to get logs from on-premise applications. And we could have done this we could have used the same Logstash instance on EKS, but with our setup, the setup we had currently, the network setup, then there wasn't a direct connection between EKS and the on-premises applications. So it was quite involved to get them talking to each other easily. So we decided to go with the less complicated way. We set up another Logstash instance on premises. Now, this was to receive logs from applications. Some of these applications were using Jelf, which is a separate log format where you send logs over UDP in a specific format. They were sending, some applications were sending over Jelf to Graylog, while some other applications it was just regular log files. So we're going to use FileBits for those. And yeah, this is an example of our inputs for that, our input configuration for that. We have over here, we are receiving logs from Jelf applications on this board. So rather than sending to Graylog, which was the service that received the Jelf logs before, instead we pointed them to this. We actually just changed the DNS to point to this service on this port, and we tagged them. Whenever they came in, we tag them like, okay, these ones are coming from our on-premise applications, and we send them to a specific index. We also have the bits, so this is where FileBits applications will send to. And then over here, we have our filters that will handle them properly, like transform them and format them. So for instance, the logs that are coming from Gelf, where they were using a log format that was a numerical log format, like 1 to 5 or something like that. So we wanted to convert them to syslog, the standard log format, so we can easily search on that in Cabana, since we're already using those from our other logs, searching on info and the rest. So this was the little scripts that I wrote to do that. And there's probably simpler way to do that, but as at then I couldn't think of it. So we convert from the integer versions to the string versions, and then this was from the other service that we're picking from. This one wasn't using Jelf. This one was sending via FileBits. It was actually sending its logs as XML files, just logging, creating XML files. And FileBits was picking up the logs from there. So we had to set up an XML filter to parse the logs and convert them into documents for Elasticsearch. We also had to add some fingerprinting because we're having some duplicate issues. We mitigated them to an issue, but eventually we decided to go with some fingerprinting so we don't have multiple copies of logs. And lastly was maintainability. How do we keep all of this maintainable? Like, how do we manage all of this without running crazy, without having things out of sync or having serious issues, discrepancies? First off, moving to Elastic Cloud massively helped with maintainability because since everything was now hosted in the cloud, we could cut out most of our infrastructure management and leave that to be handled by Elastic Cloud. So there was just one source of truth there, which was the configuration we had in the cloud. Then secondly, we also, for the configuration that we had to have on our end, the agents and Logstash, for instance, we made sure that we kept the configuration as code. So all of it was in code files that were kept in their own repository and checked into version control, so that we could track changes to them, we could keep them in sync. And eventually we added GitOps so we could have infrastructure mirror what was in the code base at any point in time. And then we also added Cabana saved objects to version control. That's like dashboards and visualizations. We made sure we check them into Git. And this came in very handy when we were migrating to Elastic Cloud because we had to take the previous dashboards we had created on our old environment and migrate them import them to the new environment. So by having them in version control, we knew that we always kept them up to date. So we could import them easily as needed. And then documentation, lots of it actually. I wrote lots of documentation on how to use Elastic for monitoring, because the idea is that everyone has to be responsible for their own applications. Like, there isn't a specific monitoring engineer that does the monitoring and tells you what they need to know. Every engineer has to know how to check up on the applications, has to be able to receive alerts and respond to them. So on some levels, I had to write some documentation to explain some things, to point out some customizations we had made, to point out some things that are unique, peculiar to our setup. and generally just added to the Elastic documentation because they have some pretty good documentation. So we just added some extra information that was necessary for our use case, and this helped everyone find out what they needed to know and easily get answers to their questions. So overall, this was a journey for me as much as for Homechoice. I think the biggest lesson I learned from it was that observability is an attitude. Like by default, I mean, you have companies that market observability tools and all of that, but if you aren't into it, they're just a bunch of pretty graphs and charts that show you just look nice, and you can look at them and feel proud. Oh, we have these charts, we have these graphs, we have all of this information. But if you actually aren't interested in getting insight into your applications and know what's going on, it's just going to be there. The tools won't work for you, they won't serve you, and you find yourself still struggling to debug or inefficiently debugging your applications. And that was one fun thing while I experienced while working with Homechoice. There was a general attitude of wanting to go deeper in this, of wanting to understand, wanting to gain insight into what the applications were doing, into how they were performing and what was going on at any point in time. And so I've learned that we need to build that observability attitude. And when we do that, it's going to be easier for us to incorporate the tools and processes. Thank you.
Shalva, that's amazing. I'm looking at myself now. There we go. That was really good. I have questions and comments, but I think let me open it to the floor and see if there's anyone who wants to jump in. Okay, let me jump in and ask a question. So what I loved about that, what I loved about that the most was how you incorporated business data with your logs and metrics. So actually, like, you know, bridging the gap between what something like Nginx is reporting and also what your application is recording, and then surfacing that in a single dashboard, so that you can see performance and you can see orders and you can see you know, availability and what the impact is on the business. The question that I wanted to ask around Homechoice, and if you don't know the answer to this one, that I maybe someone from the client would know, but are you surfacing, or is that data being surfaced, or that those dashboards being shown in like exec meetings, and are they driving management decisions and that sort of stuff, or is it purely an engineering view?
That would actually be a question for the client to answer, because I don't have insight into that part. But I believe so, because there are lots of business dashboards over there.
I can actually answer on that. We've got it running on the engineering floors on TVs. So it's not actually used anywhere else yet.
Okay. Cool. Thanks, Albert, and thanks for joining. Appreciate you joining. I think it's I'm really impressed. I think it's a great story. And yes, I think the move to cloud is a great one. And I think, I mean, it's probably worth mentioning. Often people think, specifically in South Africa, whenever I introduce myself and tell people where I work, often people think we are AWS, and that, you know, the Elastic is an AWS product. Definitely that isn't the case, which I think everyone on the call knows, but the main thing I want to highlight is the fact that, yeah, there is no partnership in terms of that AWS Elasticsearch service. Obviously, we partner with AWS for our Elastic Cloud. We have to deploy it to them because they are so prolific, and I mean, it's a good target destination for our Elasticsearch service. But the one that's offered by AWS themselves is not actually one that we what's the word, we compete against that service, to be honest. So yes, there's a lot, and I think in terms of some of the things that you mentioned, Shalva, that were not included, or some of the challenges you had with AWS Elasticsearch service, I also want to point out that security wise, basically there's very the security feature comparison, there's definitely no parity between what we're offering on Elastic Cloud and then what's in that AWS service. So yeah, I think a really great session. Thank you so much, guys. I really appreciate it. Anyone else want to jump in there? I think there was a question which Shell was answering in the chat just about Nginx logs. Shelda,
Yeah,
were you Yeah, so I think that you can you've captured your answer there. What I wanted to ask you is, are you converting? So now that you're using Logstash, I didn't look at the pipeline in enough detail to have picked this up and answer my own question. Are you converting to ECS formats on the data that you're putting into the cluster?
Yeah, we've tried as much as possible to conform to the ECS formats in the data we're sending. So yeah.
Cool. Well, I think you're gonna, given that you're on cloud, you're gonna benefit from what's coming in 7.7, and you're gonna love some of the alerting improvements as well. So yeah, thanks, Shola. Which kind of brings us on to the last and probably really short section. So like I said, up until a few minutes ago, or a few minutes before the meetup, I couldn't really think of anything that I picked up in the last 2 or 3 weeks that I wanted to share, predominantly because lockdowns had me doing 4 or 5 different jobs, including looking after kids and cleaning the house and doing my job. So it's been a little bit difficult to dive into Elastic and pick up little tips, but something that we did do for a client who was migrating from on-prem into the cloud was help them to speed up their migration of their dashboards. So they did move indexes across. I think they actually created the configuration from scratch. They didn't do the snapshotting from on-prem and then restoring on the cloud. But what they did do was they exported their Cabana dashboard. So if you are moving to the cloud and you want to try something in the cloud and try that 14-day trial, you don't have to rebuild your dashboards. You can go in our little management interface here, which is obviously a little gear icon, go into Cabana saved objects. And if you're not familiar, there's basically a Cabana index. It's not Cabana index, which basically drives the way that all of Cabana's little objects that it stores and renders. And what you're able to do is say, choose the dashboard that you want to move across the cloud. You can export it. It exports into this kind of ND-JSON file, which you can save, and then you can click over to your cloud platform and import, and you can basically bring that object across. And as long as your index pattern name works and the visualizations exist, and it'll render the dashboard. So this, in this case, this is the dashboard. You really should bring the visualizations across first. But yeah, basically, it's quite easy to do that. You don't have to rebuild if you are doing a migration. So that's a small little enhancement. Yeah, I think anyone else want to add anything? Yeah, how's it, Monet?
How's it? Yeah, so we have 2 clusters. One is our text-based search cluster, and one is our analytics cluster. Analytics cluster, we've got up to version 7.4 now, but our search is still on 6.7. One of the issues I found was the saved objects for 6.7 still exports to JSON, whereas 7 requires an ND-JSON format. Is there any sort of conversion application or script or something that's available?
Okay, so I definitely don't have an answer for you off the top of my head. I'm gonna see if Damien and Johannes are still on the call and see if they have anything to add to that.
All right, cool, thanks.
Sure.
So Tim, Mornay, Johannes here. I've come across the same issue, and my memory cache is a bit small, so I can quickly see if I can find my notes on that, but I think there is an issue because it's totally generated differently in the new versions. But let me just, I can send the information through to Tim, and then Tim can maybe communicate to you on that if I'm not in time before the meeting closes.
Oh, that's great, Scott.
Awesome. Thanks, man. Anyone else? Cool. Well, so we're going to give you back 20 minutes in your day. Please, by all means, if you have any comments, specifically going back to the start of the call, anyone has an issue with the timing, I could even move it earlier in the day if we feel that that's preferred, or we can move it back to the traditional time slots of 6 p.m. But otherwise, yeah, comments. I'm looking for speakers. So if anyone has a case study that they'd like, please, by all means, reach out to me. And hope to see everyone on the next one. It'll probably be mid-June. So yeah, I'm just gonna leave it there.